last time. Okay, let's try this one. So let's say one on the left.
Okay.
How'd you do
So on the five bit on the pounds bit at the bottom, do you like go up from the £5 until you hit that diagonal line?
it? Mm-hmm.
You look on you like then you see like where it is compared to dollars. I think that's like $8 or something.
Yeah. So in this case, it was exactly $8. It's
Yeah.
not. It's not always that exact. Okay, and the one on the right.
Is it 20 meters?
Um, clay soil is the dots, and so that is 20. Yeah, that was 20. Okay, so that one had two lines, quite unusual. Sorry. Okay, how about this one on the left?
Um, is it like um 5 kilometers?
Yeah. Let's see. Okay, one on the right.
Um, uh, did he rest like half an hour?
Yeah, and you'll be fine for part B. Okay, how about this one?
Um, I'm not exactly sure what to do.
So a standing charge is how much you get charged even if you use no water.
Okay.
Any idea what that would be?
Um, is it like 15 or something? Or
Yeah, it looks like it's 14, so it might not be clear on your screen. It looks like it's 2 squares out of 5 for the between 10 and 20. So a standing charge, fixed charge, there's a number of ways you can say it, and it's often electricity and stuff like that. Not just water, gas as well. It's basically where it starts from. So yeah, if they use zero, it's like you go to zero, go up, hit the line, go across. Let's see. That one's gonna be fine. That one's gonna be fine. Okay. These tricky ones. Okay, how about this one on the left?
So would the first one be like 3 minus 1?
Yeah.
And then the next one, um, 1 minus 4.
How did you get 1?
3 minus 2.
This isn't plus 2. This is times 2.
So would I divide it?
Yeah.
So 1.5 minus 4.
Yeah.
And then I think, is that just like minus 3 minus 4.
Well done. And how about the one on the right?
So is that like y equals g minus x?
That would be if it was a reflection in the y-axis, all the x coordinates would change from positive to negative. So it would be if it flipped the other way. If it went like that or something.
So do I need to like make the y-axis like a minus?
Yeah, so how would you do that?
I think I forgot to do that.
Sorry?
I think I forgot to do that.
It's not the x that changes sign, it's the y. So you changed x to minus x?
Yeah, so would it be like g minus y?
Well, it's just instead of y, it's minus y.
Oh, right, okay.
It's the y coordinates that changed. And what would that be if you wrote it as y equals?
Y equals g plus x.
No. If you times both sides by minus 1.
Would that be like g minus x?
No, because that would be in the bracket. It's outside the bracket.
Minus 2. Oh, okay.
Yeah. So basically, so this little diagram that I did, that's if the x coordinates change sign. This one here is the y coordinates changing sign. So y equals becomes minus y equals. And if you want, you can move the thing to the other side. Okay, any questions there?
No.
Okay. Let's try these two.
Does it mean the y-axis are like -2 or something?
Yeah.
So is it 0 -2?
And then it becomes y equals a half the f of x.
So does that mean I need to do like -2 times a half?
Yep.
So it would be like 0 -1.
0 minus 1. That's it. And one on the right.
So so is that just like y? Oh no, is that like 0 1 or something?
0 1. Correct. Let's see. Yeah. Let's try, I think, the first two. Hang on. Yeah. First two.
Is the first one like 0 5?
Yeah.
And then the next one 3 10.
Yeah. And let's skip down to the bottom one.
So when I say describe the transformation, do I need to say like the y-axis, like it goes -4 below the y-axis or whatever?
Yeah. So probably the simplest way is what type of transformation is it?
Is that a translation?
Yeah. And what vector?
0 -4.
Yeah. There's many ways to describe it. That's probably the easiest way. It's a translation and it's by that vector. Okay, how about this one on the left?
So is P like 0 I'm not really sure like what the y coordinate is.
Well, you have them mixed up. The y coordinate is up and down.
Yeah.
So it's the y that's 0. The x sine, do you know how often it repeats?
No.
So it's basically, it's like a circle, so it repeats every 360. So this one is going to repeat here, going to start repeating there, so that's 360 degrees. So any idea what P is?
Probably 180.
Yeah. And so any idea coordinates for Q?
So is Q like 270,
Mm-hmm.
and then
And for a sine graph, do you know what it goes up to and goes down to?
no.
1 and minus 1. Yeah, so that's 270 minus 1.
Yeah.
So that's a sine graph. Okay, on the right you have y equals cos x. Coordinates of A. Any ideas with that?
So I think A is like 90, 0.
Well done. And then how do we do B?
Like 180 minus 1.
Okay, what would 180 minus 1 become?
Oh, because it's y equals 2 cos of x. So do I need to? So would it become 180 minus 2?
Yeah.
And then do I need to do 90, 0 now?
Yeah.
And then I think it'll just stay as like 90, 0.
Yeah.
And so. Oh, do I need to do the third point as well?
Yeah.
And then I think that would be like 270, 0.
Yeah.
And then it'll stay as 270, 0.
Mm-hmm.
And then with 0, 1, it will like it will go to 0, 2.
Yeah.
And with 361, it'll go to 362.
Well done. So there you've done the main points. And so we'll join those up. So that's up at 2. That one stayed the same. That one went down to minus 2. That one stayed the same. And that one went up to plus 2. So that there, all the y coordinates doubled. Any questions there?
No.
Okay, so the graphs repeat every 360. And so halfway is 180. Half of that is 90. 3/4 270. And you can go from there. Sine and cos, the maximum is 1. The minimum is minus 1. And they'll just keep repeating 1 minus 1, 1 minus 1. Okay, 3D coordinates. A. Or maybe let's start with the one on the right. Might be a bit simpler to start with.
Okay. I'm honestly not sure.
Okay, so to get to um, P first, so you always start at O, the origin. So you'd have to go, let's say, across to here, then up, and then this way. So, well, how far would be the first one? How
Fine.
far? Yeah. So the x coordinate is 5. Then how many up?
3
So that's the y,
and 4.
and then 4. 5, 3, 4. That's it. Okay. Next one. B.
Yeah. So would it be like on the corner above 3 and then 3? Or
So let's see. So 0.
yeah.
So you start at the origin.
Oh, actually, yeah. Sorry, go on.
So you start at the origin. So you go 0 along the x. So you stay where you are. Then 3. What would you do there?
So you'd go up to like the mid, like to the corner of the cuboid. So you're on the edge of the cuboid, I think now. Yeah.
Yeah.
And then you go like 2/5 of the length of like the cuboid here.
The last one is the z.
Um. Um.
So the 5 would be the x.
Yeah.
How far is it for the z?
It's 2.
Yeah. And what direction is it in?
Left.
Yeah. And so it's not 2/5. How much is it?
It's is it like I'm not sure.
So this line here is the z.
Yeah.
What other line has the same length?
The line on the right.
Yeah. So what's the length?
5, I think.
That's going the other way. That's going this way. So those have the same length. Those have the same length.
Oh, is it 4?
Yeah. So this is actually 4 long. So where would we put the x?
Halfway.
That's it. And that's the point C. Okay. Any questions there?
How do you know when you get to like to go left rather than right?
So it's always x, y, z.
Yeah.
So x, y, z. So they said go 0 along the x, so we just stay where we are. Go 3 up on the y, and so we go 3 up there. And then we go 2 along on the z. So we knew that this one was 4, and so this would be halfway. So you can match them up with other things. So all the 5s are all that length going across. Then all the 3s are going up, and all the 4s are the diagonal lines. So they're all 4 long because it's a cuboid.
Okay.
Yeah. Okay, try the one on the left.
So what do you want? All right. So I think here I need to do like so go 3 across on the x-axis.
Mm-hmm.
Then Is that just the point for Q?
That's it, yeah. Okay.
And then the vertex S. And then is the vertex S like so 3 and then 2 and then 4.
Well done. Got it. For sure. Okay. How about this one?
So I think the coordinates of R are 6, 6,
So maybe let's label the lengths.
okay.
So let's say along the X, how long is the cuboid?
How long is the Q? 6.
What's the height?
2.
And depth?
4.
Yeah. Okay. So to get from O to R, or if you like, you can start from N and say what you'd have to do to get to R. And what that will change.
So the coordinates of vertex are like um 6 or wait, sorry, so did you say to try and do from like N to R?
So yeah, imagine you went from, so we already know N, so what would change if you went from N to R?
Is N to R like 6, 0, 0?
Right? And so how will that change the coordinate?
You wouldn't go on the Y or Z axis.
So what coordinate will change? You've got N is at 624.
The Y and Z coordinates.
So they wouldn't change because we didn't go up or down and we didn't go deep. We just went left.
Yeah.
So left and right is X. So what will be the new coordinate?
Oh, is that like -6?
Yeah.
So would all of them change?
No, we didn't go up or down. We only travelled left.
So only the x coordinate will change.
Yeah.
So is that just like -6?
Well, we were at 6 and we went 6 to the left. So it's -6 from the x.
Yeah.
So we were at 624. We went 6 left along the x.
So is it? Oh, so 024.
Yeah. 0, 2, 4. That's it. Yeah, so for these ones, it helps to have a reference point and to travel from there. Like, what did you have to do to go from one to the other? You have to subtract 6. You have to go 6 back on the x, because it's kind of difficult to know from the start. Okay, this one, how do we do this?
Yeah, so so is x like 126?
Yeah, give a reason for your answer.
Wasn't it like something like alternate angles are the same or something?
Yeah, alternate angles are equal. That's it. Alternate angles are equal. Okay, how do we do this?
Would that be 200?
So that's not the external angle. The external angle is the little angle between the straight line.
Oh, so
that's the alternate. That's the exterior angle.
would it just be 20?
So it's just 20. Yeah. Yeah. So it's not the full 360. It's just 180. Okay. How about this?
Um, do I need to substitute the 3x plus 2 into like somewhere.
No. So it says this is the length.
Yeah.
You have to find the width. And they give you the area. Any equation that connects those?
Would it be 3x squared plus 5x plus 2 divided by 3x plus 2?
Yes. So length times width equals area. This was 3x plus 2 times by something gives us that. And you can divide it, or you can just try by looking at it by inspection.
Yeah, so um uh so would it be like x and then
And you can look at just the number, the last number then.
plus 2
2 times 2 would make 4.
plus 4. So x plus 1.
Well done. That's it. Yeah, so lots of words, but fundamentally a simple enough idea. There's two shapes. If there was just one shape and they just said its length is 3x plus 2, its area is 3x squared plus 5x plus 2, what's its width? You know what you have to deal with. And it's probably easier to just kind of figure it out by saying what times what gives you 3x squared, what times 2 gives you 2, and put it in that way. And the middle bit, you kind of just, it works itself out. Any questions about that?
Yeah, sorry, I'm a bit confused because I'm not sure like where like when you times those two together you get 5x.
So if you expand these double brackets,
Yeah.
So you get 3x squared as the first thing.
Yeah.
You get plus 2 as the last thing.
Yeah.
And in the middle, outside and inside, you would get 3x times 1, which is 3x, and 2 times x, which is 2x. And you'd simplify it, 3x plus 2x.
Yeah, all right, thank you.
5x. So this one is like, if you wanted to check your answer, you could, but there's no way that this has to be an x first. This has to be a 1 second, and so that will definitely be plus 5 in the middle. You don't even have to, you get that for free, basically. Okay, left.
And so, is that like 9 times pi?
Yeah, 9 pi, fine. One on the right.
8 pi.
Yeah, and the circumference formula is most forgotten of them all. Okay, how about this one on the left, top left?
Is it like 16.5?
Yeah.
Is it 17.5?
Yeah, and so even though 17.5 would round up, it's called the upper bound. It's on the boundary. How about bottom right?
Is it 167.5?
Mm-hmm. Oops. And B?
168.5.
0.5, totally fine. So here we can't. I could actually. But anyway, how would we do the one on the right, part B? measure the bearing of H from L.
If I worked out how many centimeters there are, I just times it by 5.
Yeah, and part B.
That's the bearing of H from L. Isn't it like so you'd get a protractor or something, and then you work out the angle, and then you minus it from 360.
So which angle?
Like the smaller angle of the two, I think.
What letter is next to it? L or H? So let's say there's two interior angles. You've got this one here and this one here. So which is the bearing of H from L?
The red one?
No. These are always written in reverse. Basically that means from L to H. Of H from L means from L to H. And so it's always the angle between the line that connects them and north.
Okay.
And you'd measure that with your protractor. So how would you do the one on the left?
So would you like do 180 and then do the next angle after that, and then like add it up?
So I think you'd have to join them up first. Okay, and so what angle is it referring to of L from Y?
So from Y to L.
Yeah. To L. And so which angle would that be? The bottom or top?
The bottom.
Yes. So that's the angle that you measure. The angle between the line that connects them and north.
Okay.
There's a little trick to this one. I'll see if this isn't too difficult. I recently discovered this thing. So we put our cross where they cross over. I make this small. Oh, I don't even. So that's lined up. What does it look like the angle is?
It looks like something like.
Hang on, I have to line it up with 0. So the 0, okay.
It's like around about 49.
So let's say 49, and so we close this. Full marks.
And measure the bearing from. Is that it?
So bearings strangely have 3 significant figures, so you have to write down 049.
Oh right, yeah. Okay.
Okay, there we go. Okay, how do we do this?
So if you get the one coordinate of the shape, so like so 2 1, and then you go minus 3 2. So you take that coordinate 3 points left, and then 2 up, I think.
Yeah.
2
3, 1, 2, and you do it for all of them.
Yeah.
And then just draw it. So let's say 1 2 3 1 2, and maybe I can speed it up a bit, and that's 2 across, and then we join those up. Yeah, that's alright, won't give you any trouble. Oh, this thing. Alright. What about this?
Because like Uh, when all 3 points of triangle are touching in the circle, otherwise it's a right angle triangle. Something like
No. You can make a scaling triangle. 3 sides touching.
that. Oh, is it because uh, the diameter of a circle
Yeah.
like 90 degrees next to it or something?
Yes. So it's basically a special case for the angle at the circle, which is the one we have here. That's the one we say at the circle or at the circumference, is half the angle at the center. And that's because this one here is 180 degrees, and so that one must be half of it, which is 90. Yeah, if you have if it's a diameter, then it's a right angle triangle. Okay, one on the left.
So, is that like minus A plus B?
Yeah, minus A plus B. How about top right?
So minus B plus A.
And bottom right.
So minus B plus A.
Yeah, so totally different shape, totally different thing, but what was that? Top left.
So minus 6A plus 6B.
And next one. EF.
Yeah. It's minus 6A plus 6B.
No, that would be like ED would be the same as AB. Because it's the same size and same direction. So that would be minus 6A plus 6B. What side will be the same as EF? Same size, same direction.
Eta. So
Any side that has the same length and direction as E to F?
is it 6A?
Yeah, basically that's the same as O to A. It's also the same as C to B, but we don't know that one. So that is 6A. Bottom left? No, let's leave bottom left. Top right.
So A plus B.
And 2.
Minus A plus 3B.
Yeah, minus A plus 3B. Okay, I'll go back. So there's gonna be a million vectors things. Click. There we go. Okay. Okay, let's try the one on the left.
So like 30.
And B.
Uh, 20 kilometers.
What would be part 3 for this one?
So it would be like, would it be 1-5?
Yeah. Yeah. Okay. Bottom left.
1:45.
Yeah, and if it was a calculator paper, just put that in your calculator. Top right.
64.5.
And B.
65.5.
Okay. Yeah. Yeah. Bottom left.
Bottom left. Minus A plus B.
Bottom left for this one.
Minus 2A plus 4B.
Yeah. Okay, we'll just continue these ones. Let's see. Okay, let's say the one on the right.
Okay, so I think it's like 3A plus B.
One on the left.
So minus 3B plus A.
Right.
So is that like B plus A?
From C to A.
Oh, is that 2A?
Yeah. And so part 2.
Beach. Minus B minus A.
Yes. Okay, how about this?
Is that 0-4? So 0 and then 4.
Because what, sorry?
Is it 0 and 4?
So A to B. So it's going to be a vector. And so how do you get from A to B? So 0 would mean you'd stay at 3.
So also -6, -4.
Yeah. And after that, it's going to be data. How was that for you, Andrey?
Yeah, that was good, thank you.
Shall we continue this next time?
Yes, please.
Okay, so questionnaires is data, which is the final quarter of, maths in general. And so after that will be 2 mark questions, and I think we'll almost certainly get to 2 mark questions next time.
Yeah.
Any questions from me in general?
No, I probably think I should probably just tell you as well. I've got my first maths GCSE in January, which is coming up. So
Yeah. Your mum emailed me, and she told me all the extra lessons and stuff.
yeah.
And it was good because we were finished, everything in the book that I wanted to finish, and so this was the natural time to do revision anyway, so it worked out. Anything else?
I don't think so.
All right, well done, Andrey, you did great.